Recall that Jang has to earn at least $175 weekly to meet his expenses while going to college. He works 2 part-time jobs, the first job paying $9 an hour, the second job paying $10 an hour. To have time for his studies, Jang wants to work no more than 20 hours a week. We came up with this system of inequalities describing the situation. X plus y is less than or equal to 20, and 9x plus 10y is greater than or equal to 175. Where x represented the number of hours that Jang worked weekly at the first job, and y was the number of hours that Jang worked weekly at the second job. And we make this note that since both x and y refer to a number of hours worked a week, they can only take on positive values or 0. We're asked to graphically solve the system of inequalities. So what we're going to do here is we're going to graph both of these inequalities using techniques we've learned in the past. But in the end, the solution set is the region that satisfies both inequalities. So let's say we have x plus y is less than or equal to 20. So let's use this. What scale should we use here? Let's use a scale of 10. No, not 10. Let's use a scale of, how about 2? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Alright, so now let's see. We have x plus y is less than or equal to 20. I will graph that in blue. Alright, so I'm thinking x plus y equals 20 for the moment, and finding intercepts if x equals 0, so the y-intercept, or, yeah, if x equals 0, then we would have 0 plus y equals 20, so y equals 20. So we have the y-intercept at 0, 20. Similarly, if we let y equal 0, then we would have x plus 0 equals 20, and so x equals 20, and so we have the y-intercept, the x-intercept at 20, 0. So plotting those points, 0, 20, 20, 0, since it's an or equal to inequality, we'll use a solid line. And now maybe we use a test point. So let's see, the test point, well, the line doesn't go through the origin, so I'm going to test the origin. So test 0, 0. And 0, 0 would imply that 0 plus 0 is less than or equal to 20, and that is very true. Now, normally, if this were an individual inequality, we would shade at this point. But I don't shade until I see both inequalities. So what I usually do now is I put some little arrows saying I would shade on that side of the line. Alright, now the second inequality, we have 9x plus 10y is greater than or equal to 175, and for the moment I'm going to think equals 175. So letting x equal 0, then I have 10y equals 175, which means that y is equal to 17.5, and so I have a y-intercept of 0, 17.5. Letting y equals 0, I have 9x is equal to 175. Dividing through by 9, x is equal to approximately, let's see, 175 divided by 9 gives me 19.4 approximately. And so I have an x-intercept of 19.4, 0. Plotting those points, 0, 17.5, 19.4, 0, and drawing a solid line through those points. All right, and again, I can test a point here. I'm going to again test the origin. So testing the origin would give me 9 times 0 plus 10 times 0 is greater than or equal to 175. And so 0 is greater than or equal to 175. That's false. So I would not shade the region containing 0, 0, but rather I would shade the region above that line, that orange line. And so now if we look at those two boundaries that we drew and the regions that we would shade, we only shade the region that satisfies both inequalities. So now remembering that the x and y values can only take on positive or 0 values, I will shade this region, this thin strip between the two lines. Now we're asked to check the solution set with a sample test point and interpret the sample test point in the solution set in terms of Zhang's problem. Alright, so let's go back to the graph and find a test point. And I'm going to use the point, let's see, I'm going to use this point right here at, it looks to be 10, 9. So it looks like 10, 9 is a valid point in the region. So let's try that point. Let's see what happens. Alright, so let's check with 10, 9. Alright, so let's see. In the first inequality, 10 plus 9, is this less than or equal to 20? Well, that gives us 19 is less than or equal to 20. That's a true statement, so that works. And let's see. 9 in the second inequality, 9 times 10 plus 10 times 9, is that greater than or equal to 175? Well, 10 times 9 is 90. 10 times 9 is 90. 90 plus 90 is 180. Is that greater than or equal to 175? Yes. So 10, 9 is a specific point that satisfies both inequalities, and it is in the solution set. So now let's interpret that point. So Zhang can work 10 hours at the first job and 9 hours at the second job.